welcome to this episode of Night Sky News with me, astrophysicist Dr. Becky Smethurst. This is a show where we chat about what you should look out for in the night sky in the next few weeks, and we chat about what's been happening in space news in the past few weeks. There's chapter titles down here if you want to skip ahead to any specific news story, and if I mention any scientific research papers, they will be linked to read for free in the video description down below. So without any further ado, let's kick things off and start by looking up. Alright, let's start with the planets in the morning sky, because for those of you who haven't been up before the sun lately, you might not know that there are actually 4 planets visible in the morning sky right now, all nicely in a line above the eastern horizon before sunrise. So from top to bottom, you've got Saturn, which is sort of the faintest, very yellowish in colour. Then you've got Mars, which will be fairly bright, have that characteristic reddish colour. Then you've got Venus, which is the brightest, you literally cannot miss it. Then you've got Jupiter below that, which will also be very bright, but that'll be the closest to the horizon. The closer you are to the equator, the higher they will rise before the sun comes up, but much further south or north there, you might struggle. So in the UK, for example, Jupiter will be really low, sort of in that glow of the sunrise, making it really difficult to spot. If you're not sure what you're looking at, then don't worry, because the crescent moon, or the toenail moon as I like to call it, is actually going to join the party towards the end of April, slotting between Mars and Saturn on the 25th. It will just be below Mars by the 26th, and then below Venus on the 27th, becoming an ever thinner crescent every day. So if you're still not sure which planet is which, or even whether you're looking in the right direction, hopefully being able to pick out the much bigger and brighter crescent moon, which is much easier to spot, will make it so that you do know what you're looking at. So that way you'll know which ones are Jupiter and Venus, so you can watch them creep closer and closer together for their conjunction on May Day morning, the 1st of May. So if you're getting up before sunrise for any May Day celebrations, maybe you're going to Magdalen Bridge in Oxford, see if you can get somewhere high and look towards the east to see if you can spot this, because they're only going to be 0.2 degrees apart. So for context, if you hold out your little finger at arm's length, your little finger spans a degree in the sky. And we're talking about 0.2 degrees here. So a fifth of your little finger distance for the 2 most brightest planets in the sky is going to be spectacular. There's one more planet visible at the minute that I haven't mentioned yet, and that's Mercury, which is visible in the evening sky just after sunset for about an hour or so. It's reaching what's known as its greatest elongation, so it'll be the highest it can possibly reach in the sky, making it easier to spot on the 30th of April. It's also going to be very close to the star cluster Pleiades, which is one of my favourite sights in the sky. If you actually have some binoculars, you should be able to see both of them within the same view from your binoculars. And then by the 2nd of May, the moon has also swung to the other side of the sun to join them once again as a crescent or a toenail moon, again to make finding Mercury in the sky that much easier. And in between all those crescent moons is obviously a new moon as well. So that weekend of the 29th, 30th of April is going to be a great weekend to look for fainter objects in the sky, like galaxies and nebula. So a great time to do spot of astrophotography if you're up for that. But also if you're in the southern tip of South America, the new moon will cause a partial solar eclipse of the sun on Sunday, the 30th of April in the evening, around about 6 p.m. local time. About 50% coverage of the sun. So it'll look sort of like the moon has like took a bite out of the sun. Remember, don't look at the sun directly. You should use eclipse glasses if you have them, if you can get your hands on them. Or you can look at it through something with a hole, like a pinhole camera. You project the sun through that. Or even something with many holes, like a colander. If you hold that up to the side of your head and let the sun project down and through it to the ground, you should see a projection of the eclipse on the ground. Eclipses never happen alone though, because 2 weeks later we're going to have a full moon with a similar alignment, which means we're going to have a total lunar eclipse visible across the Americas, Europe, and Africa. This is where the moon passes into the Earth's shadow and it turns red as it passes through the Earth's sunset shadow, as light refracts through the Earth's atmosphere. This is going to be visible as the moon sets on the morning of Monday the 16th for those in Europe and Africa, where it's actually only going to be a partial eclipse and moon will appear sort of just tinged red. And then visible on the 15th of May, my birthday, for all of you across the Americas. It'll actually be a total eclipse across the east coast of US, Canada, Mexico, across the Caribbean and all of South America as well. But the west coast of North America is only going to see a partial eclipse as the moon rises on the evening of the 15th of May. I'll pop a link in the video description so you can actually work out how much of an eclipse you'll see and at what time for your specific location. One more thing before we get to space news is that the Eta Aquarids meteor shower is going to be peaking around about the weekend of the 6th and 7th of May. Now, the best view is actually going to be in the southern hemisphere, where in the darkest skies, you're going to get some at like 60 meteors an hour. But in the northern hemisphere, you're looking at more like 30 meteors an hour. The meteors in the Eta Aquarids shower actually are caused by leftover bits of rock and dust from Halley's comet, which passed close by in 1986, and it's named after the constellation which the meteors all appear to be coming from, Aquarius. So the trick is to look anywhere but at Aquarius. If you do plan to either stay up late or get up extra early to see some meteors, it is best if you're in a big group of people. You've got more chance of spotting more meteors, but also the longer you stay out, the more you'll also spot as well, because your eyes will adjust and see even the faintest of meteors. So make sure you get comfy. Lie down flat to do this. Don't hurt yourself by cricking your neck looking up for ages. All right, that is enough for looking up at the night sky. Now let's come back down to Earth and chat about what's been happening in space news in the past month. Let's start with everybody's favorite thing right now, an update on the James Webb Space Telescope. So if you remember last month, the 18 mirror segments have been aligned to perfectly focus the telescope, and we got that incredible image that wasn't even a science image, it was just a calibration image. And this has been done for the NIRCam detector, James Webb's main imaging detector. So James Webb actually has 4 detectors on board, plus a guidance sensor as well, and they each are designed to detect different things for different science cases. And at the beginning of this month, NASA shared the good news that the telescope was now aligned for NIRSPEC, NIRISS, and the guidance sensor as well. The full alignment of all 4 detectors plus the guidance sensor on board, though, couldn't actually happen yet. And that's because they were waiting for that 4th and final detector, MIRI, to be ready. For the past 3 months since that launch, it has been cooling down to just 7 Kelvin. It has to be that cold because you have to reduce the amount of noise from the detector itself that could masquerade as signals from space. It is an infrared detector, right? It detects the light given off as thermal radiation or heat, by all things, whether it's me, you, or a lump of metal. And that's true of all 4 detectors on board, right? Which were all cooled to about 90 Kelvin or minus 183 degrees Celsius, thanks to that huge sun shield that JWST has that unfolded after launch. And 90 Kelvin was enough for the likes of NIRCam and NIRSPEC that detect light down, at the shorter wavelengths of light in the near-infrared because it is closer to the optical. But because the amount of light given off at each wavelength is dependent on an object's temperature, right? The higher temperature objects give off more light at shorter wavelengths from the optical and the near-infrared, and lower temperature objects give off more light at the longer wavelengths that MIRI detects, including from the detector itself. So to eliminate any of that, noise, that infrared radiation coming from the detector and not from space, MIRI had to be cooled down to 7 Kelvin using an electrically powered cryo cooler, which is easy enough as you get down to around about 15 Kelvin, and then it becomes incredibly difficult to get lower than that. It's sort of what's known as like a bottleneck or a pinch point where it becomes incredibly difficult to keep lowering the temperature. Once you are past that, though, it gets a little bit easier again as you get down to 7 Kelvin. Thankfully, it got past that point all right, and NASA announced on the 7th of April that MIRI had reached its operating temperature of 7 Kelvin, just 7 degrees above absolute zero. The team then put it through a health check to check all the systems were working all right, and now they'll start to take some test images just to check the alignment of the telescope as mirror positions again, and also to test the performance of MIRI as well. Now, if you're curious why we wanted to detect down to such low infrared wavelengths, it's to detect the cooler objects in the universe that are shrouded in, cocoons of dust like star-forming regions or planets forming around stars as well. But also because light from very distant objects is redshifted, it is shifted to longer wavelengths by the expansion of the universe. Any light that was given out by very distant galaxies in the very early days of the universe, it might have been given out as visible light that we could see with our eyes and we could detect with the Hubble Space Telescope, but now it has been shifted so much into the infrared wavelengths that MIRI is able to detect. And so this is what it has been designed to do. If you want to know more about MIRI, check out the interview I did with Dr. Sarah Kendrew from the MIRI Science Operation Team last year. I'll link it in the video description down below. Speaking of temperature in the infrared, what in the universe is going on over on Neptune? A study by Roman and collaborators was published this month, which found that from 2003 to 2018, the average temperature on Neptune dropped by 8 degrees Celsius. Again, to do this, they looked at the infrared light from Neptune using a whole host of different ground-based telescopes from Hawaii to Chile over the 15-year period. Again, from how bright Neptune appears in different wavelengths in the infrared, you can work out what is its temperature and how does that temperature change from its poles to its equator. You can also just let in wavelengths of light that come from very specific molecules as well in the atmosphere, like ethane and methane, and you can see how they change with time and also with latitude in Neptune's atmosphere. Because Neptune spins on its axis with a 28-degree tilt, very similar to Earth's 23-degree tilt that gives us our seasons over the course of one Earth year, as the northern hemisphere points towards the sun in northern hemisphere summer and points away from the sun in northern hemisphere winter. Neptune takes 165 Earth years to make one orbit around the sun, so its seasons last way longer than our seasons do here on Earth. You know, they last a quarter of Neptune's orbit time, which is around about 41 Earth years or so. Much longer than just the 15 years probed here by this study. So they're not even viewing here an entire season, just a fraction of a season. But you can still see some changes in the temperature as Neptune has slowly tilted its northern hemisphere more towards the sun and us here on Earth as well since the mid-noughties. In this study, they've seen significant changes in the concentration of methane and ethane at the poles, suggesting there's complex weather systems, right, which end up giving you these different temperatures at the poles and the equator like here on Earth. The difference in temperature between the pole and the equator was only about 8 Kelvin in 2003, or 8 degrees, right? But by 2018, it was about double that, with even larger differences in 2020. We don't know why this has changed so quickly. Now, you might think, well, 15 years, that is a very long time. That's not exactly quick, Becky. But actually, if you think about it in terms of like Earth seasons, right? To get an 8-degree change in Earth seasons, say, okay, here we're in the UK, right? We go from probably about 0 degrees in the winter to 20 degrees in the summer on average, right? So to have an 8-degree temperature change, you would probably need an entire season to go by to have that temperature change. An entire season on Neptune is 41 years, not 15 years. So there's obviously something really complex going on in Neptune's gas giant atmosphere. So this is just another argument for an extended mission to Neptune, like the Cassini mission we had around Saturn or the Juno mission that we've currently got around Jupiter. No mission to Neptune has been approved by either ESA, the European Space Agency, or NASA, or any other space agency, right? So we have got a long time to wait yet before we get any answers about this, you know, in terms of like approval, design, build, launch, and then what, the 10 years it takes to get to Neptune? So I don't know whether even I'll still be working in astrophysics by then, but perhaps there's a kid out there watching this right now that might be on that mission science team one day. All right, let's stick in the solar system for now and talk about this comet that Hawaiian collaborators have spotted with the Hubble Space Telescope. Known as Comet C/2014 UN271 or Comet Bernoulli-Bernstein, which they reckon is the largest comet nucleus we have ever seen. So what do I mean by that? Well, comets are lumps of rock and ice that are left over from the formation of the solar system. And as they get closer to the sun, the ice melts, it gives off gas trapped in the rock, and they get these huge tails, which can stream hundreds of thousands of miles into space. The biggest comet tails sometimes even reach over 100 million miles long. Now, this comet's tail is not that big because it's nowhere near the sun yet. It's 2 billion miles away on the edge of the solar system. But its nucleus, that lump of rock and ice in the middle, Hawaiian collaborators have estimated it to have a radius of 60 kilometers, plus or minus a 7-kilometer uncertainty. that makes its diameter around about 120 kilometers across, right? Around about 80 miles. The previous record holder was about 100 kilometers across, only about 60 miles, so it's way, way larger. For context, the M25 motorway around London is smaller than that, at about 80 kilometers in diameter at its widest point. The state of Rhode Island in the US is about half the size of this comet at about 60 kilometers wide, and the state of ACT in Australia is also smaller than this comet at only 85 kilometers long. And okay, yeah, it's always cool to find like the biggest of something, but the reason why this discovery is so important is because it helps us to better understand the Oort cloud at the edge of the solar system. Kind of like a much less dense asteroid belt with lots of lumps of rock, whether that's asteroids or comets. Now, the Oort cloud itself is too faint to see. It's very far away with lots of very small lumps of rock. But this is where comets come from, right? So as they come into the inner solar system, we're essentially observing like a sample of what's out there. And by asking, what's the smallest rock we can see? What's the biggest rock we can see? The biggest comet that we can find? We're essentially getting a better idea of the distribution of the size of rocks out there. How many smaller ones are there? How many larger ones are there? Where is the peak, the average size? And then with that distribution, we have a better idea of what the Oort cloud is made of, and then we can work out what's the mass of the Oort cloud as well. Now, having found this comet that is much larger than the previous one we had, that might mean that there's more heavier rocks out there in the Oort cloud, and it could be heavier than we originally assumed as well. And then that would have implications for our models of how the solar system formed and how many heavy rocks actually ended up out there, flung out into the far reaches of the solar system. That is the important thing here. Not the fact that this comet is headed this way at 22,000 miles per hour, which is, I know, what a lot of news websites led with. Yeah, because half the comets in the solar system are pretty much on their way towards us, right? Because they're on the part of their orbit that brings them in closer to the sun. Earth also being relatively closer to the sun than the Oort cloud is. And, the other half happen to be moving away from us doesn't mean that it's on its way actually here, right? This comet C/2014 UN271 is not a danger to us. It's not heading towards Earth. It's only going to get to about 1 billion miles away from the sun, which is just past the orbit of Saturn, before it turns back around again and heads back to the Oort cloud. And that won't be till 2031. It's very unlikely that we're even going to be able, like me and you are going to be able to see that with naked eyes or with amateur telescopes in back gardens either. Despite its size, this is not going to put on a spectacular show like the smaller Halley's Comet did, or Comet hale-bopp. Alright, last but not least, let's go a little bit further afield now, from the largest comet ever found to possibly the most distant galaxy ever found. This study by Harikane was published this month, which was a detailed search for many distant galaxies using something called the Lyman break technique. This is the same technique that I talked about in my recent video on the star Earendel. So because the universe is expanding, light that is emitted in the optical wavelengths, it gets redshifted, stretched to longer wavelengths down into the infrared. And as it travels through space, a very specific wavelength or color of light is absorbed by hydrogen gas. This is known as the Lyman alpha absorption. And the light from distant galaxies is constantly redshifted to that wavelength as it travels through the universe. So what you end up with is this big drop off in the light so that you detect a galaxy at longer wavelengths but not at shorter wavelengths. Now the drop off is marked by the distance at which that first absorption happened at. So if you can pinpoint that, you know how much the light has been redshifted and then how far away the galaxy is, using our model for the structure and expansion of the universe. So in this study, they actually searched for galaxies that had this dropout in the light using data from the Hubble Space Telescope. And they found a really promising candidate, which they estimated to have a redshift of at least greater than 12, meaning that galaxy would have been 13.4 billion light years away when the light first left it. But if you correct for the expansion of the universe, it would now be 34 billion light years away. Harikane and collaborators then observed this candidate galaxy with the ALMA telescopes, which see from the far infrared into the microwave, so much longer wavelengths than, say, the James Webb Space Telescope. And they got what's known as a spectrum of the candidate galaxy, where you take the light, split it through a prism so that you get a trace of, how much of each different wavelength do you actually receive. Now, unfortunately, this wasn't to get at that actual Lyman break drop-off that I was talking about before. That's actually at shorter wavelengths than ALMA can detect. This is what the James Webb Space Telescope has been designed 4. But with ALMA, you can hope to spot an emission line where you have an element or a molecule that's giving out light at a very specific color or wavelength, and you can use as a marker to figure out how much the light has been redshifted. You know, in the same way before we had the hydrogen gas that was absorbing a very specific color of light. This is just caused by electrons jumping around in the atom. They either absorb light to make a jump up an energy level, or then they give it out to drop back down again. Now, usually these emission lines are incredibly bright. The galaxies that I look at, that are relatively nearby compared to this, have these huge big peaks at these very specific wavelengths. But since this galaxy is so distant, these emission lines are incredibly faint. And so the spectrum you get with ALMA is very, very noisy, and you need statistics to be able to pull out any detection. Now, this feature here, marked with a little red arrow, apparently can't be explained by just noise as random fluctuations, right? And so the authors of this study think it was actually an oxygen emission line that would usually be given off at 88 micrometers in wavelength, but it's now been detected around about 1260 micrometers, meaning the galaxy has a redshift of 13.27. Meaning the light from this galaxy was given out when the universe was only 320 million years old, and the light has been traveling to us for 13.5 billion years. This knocks GNZ11, discovered in 2015 at a redshift of 11.09, off the top spot. However, for all studies like this that can't get at a proper infrared spectrum, you know, the kind of thing that we've designed the James Webb Space Telescope to be able to do, there is obviously a lot of uncertainty when you're working with these Lyman break dropouts and the very, very noisy ALMA spectrum. And indeed, the data could also fit just a dead galaxy, no longer forming new stars at a redshift of just 4, only 12.25 billion light years away. It's still pretty far, but it's not the furthest. Again, this is what the James Webb Space Telescope has been designed to do, and it's why we're all so excited. You know, get an infrared spectrum, pinpoint exactly when that Lyman break actually occurs for HD1 and GNZ11, and confirm which one of them is further away. But probably in the process, spot even further away galaxies where that Lyman break is beyond what Hubble can detect, right into when the first galaxies and stars are forming. All I can say is roll on summer when we'll be getting the very first science data back from the James Webb Space Telescope. Alright, that's it for Night Sky News for this month. I know some of you are going to be wondering, why didn't she cover the W boson and its 1% change in its mass? But I'm an astrophysicist, not a particle physicist. But I do know that Fraser Kane over at Universe Today had a great interview with Dr. Paul Sutter, who's an expert in all things like this. So I'll link that interview in the video description down below if you want to check it out. As always, if you take any images of the night sky, send them my way over on social media because I love to see them, and I'll share my favorites as well. And if there are any breaking space news stories between now and next month's Night Sky News, I'm going to be making a YouTube short about it as well. So look out if any of those pop up. But until then, everybody, happy stargazing. Light struggle. So in the UK, for example, that was like, for example, Jupiter, but smushed into one. The best view is actually going to be in the southern hemisphere, where in the darkest skies you could get a study by Roman and collaborators was published this month. Comet C/2014 UN271, or Comet Bernardinelli, or Comet Bernardinelli. Comet C/2014 UN271, or Comet Bernardinelli-Berenstein. Oh, so happy that I said it right. I paused. Also known as Comet Bernardinelli-Bernstein. Bernstein. 14 UN271, or Comet Bernardinelli-Bernstein. Roll on summer when we start getting the very first James Webb Science data. So close. Turn around every now and then, I get a little bit sad that I can't see every total eclipse.